Well, thank you, Susan, and welcome everyone in joining the discussion today. Thanks for investing some of your precious time during this business day. I'm hopeful you'll have more than a few takeaways. And this will be interactive in that from time to time, we're going to ask you to actually contribute some of your thoughts and perspectives on this matter. And what I found when I work with people in a presentation like this is we learn from one another as we enter into the chat stream along the way. So we're going to talk about risk-based testing, and as it provides a very systematic way of supporting the kind of decisions that we need to make in order to optimize the allocation of finite resources that we have on a project. We never have enough time and people and equipment and that sort of thing. And so how do we make decisions that best allocate that in order to improve our stakeholder outcomes? And we're going to touch on these 5 different objectives. And we're going to revisit these at the end so we can check them off to see to what extent you've actually benefited from the time that you're going to invest today in this webinar. So we'll just talk about, so why is it needed? I'm interested in what some of your thoughts are based on your own personal and professional experiences. We're going to define it, and we're going to briefly compare several different approaches to analyzing quality risks. And we're going to go into some detail with 2 of them. We're also going to do a little brief brainstorming session about what in our respective environments drives risk and the kind of things that we need to reveal as part of verification and validation and testing. And then we'll pull it all together. We'll kind of wrap it up with an 8-step approach. We're going to show some examples along the way. So again, at any point, if you have a question or clarification, Susan will hopefully recognize you and you can ask either in the chat stream or whatever. But let's go ahead and get started. So if you've been involved with the software in or out of business for 1 year or 40 years, you likely have already seen a dramatic trend, and that's there's more and more pervasive software. In an automobile today, there are hundreds of millions of lines of code of software with distributed processors. And in fact, with today's EVs, electronic vehicles or electric vehicles, we're seeing that whereas before software was just part of a car, a growing part of the car, it's actually determining now the price or the value of a car. So lots of software in almost everything that we touch, Internet of Things, toasters and crock pots and everything have processors in them, and software is pervasive. It's increasing in size and it's increasing in importance. And because of that importance, we've really got to work diligently, effectively, and efficiently at getting it right. And as we probably all know, to varying degrees through our experience, and if you read in the trade press, that, the ugly secret is that software fails, and it fails all the time. In this article by my longtime associate, Bob Charette, this was published in IEEE Spectrum, billions and billions of dollars are wasted. And if you want to see the detailed laundry list, you can go take a look at that IEEE Spectrum article, which is kind of depicted as one of the data sets in the right-hand side. Point being, over decades, many quite dramatic software failures that cause extensive consequences. So I'm wondering how many of you would agree. In fact, this is an early opportunity to try using the chat stream. Tell me yes or no if you agree with the assertion here. Testing any kind of real world system is potentially, because of its magnitude and its complexity, potentially is an infinite task. Maybe it just isn't quite infinite, but it just seems like that as you're diving in. So throw into the chat stream, do you agree or disagree with that statement? We're starting to get some responses from a few. Just kind of a warm-up question. So whether it's infinite, it often is perceived by many of us as being overwhelming. And where do we even begin? So as we move on, let's take a look at why is it such a overwhelming kind of problem to solve? Well, software might be too complex to test exhaustively or completely. Programs may have many states. and more states than we're able to test. There may be excessive range of inputs, just too large to exercise all possible inputs in order to fully test the system. And often we don't have all the execution environments or test beds in order to fully test in the way that our software systems are going to be used in the real world. So that's just kind of a sample of some of the reasons that frustrate us. We may have insights into these kinds of drivers, while the conversations we have with other stakeholders might not be as apparent to them as it is to those of us that have a responsibility for verification and validation. Let's go on here and take a look at, think about your own personal experience. And in the chat stream, just jot down a phrase, a sentence or so that just says, what is top of mind for you in terms of the challenges that you've met or will be meeting going forward soon in terms of testing, either from your perspective as a verification and validation professional, or a project manager, or a business analyst, any type of role. From your perspective, what have been some of your challenges? Go ahead and enter that into the chat stream right about now. Each of us are touched in different ways by this challenge of getting things tested in the constrained time that we have. When in the life cycle we're invited to participate. Sometimes it's wait, and then hurry up kind of experience. Let's proceed and take a look at what we can do with risk management. So the magnitude of the cost to the software development life cycle that's part of the testing effort is really considerable. Testing activity might cost as much as 40% of the overall software development value. It's also been known for a long time that the earlier one finds a defect and the earlier opportunity for them to make a decision about corrective action, the less expensive it is. The less expensive it is to find a defect, and the less expensive it is to correct the defect if that's the business decision to take. The trouble that we often find is that we need a smart approach to the testing, because commonly the testing doesn't receive sufficient attention. It's because of the allocation of time. There are restrictions or constraints on our time. This is becoming more profound as we are moving towards agile approaches, where we're having 2-week sprints, and there is no software to test perhaps until the later part of a 2-week sprint. It's a common concern for many people that I work with in testing. And so fairly late in the cycle is when we allocate whatever limited resources we have, and the spend is quite considerable. And in the case study here, you see another one of the many consequences that's kind of a expansion or elaboration on the list of consequences that we saw earlier. And here, if you just take a look at it, Oxford Health Plans. And the loss here was their stock price dropped from $68 to $28 in one day. They wiped out $3.4 billion in corporate value. And they later were litigated and had to pay $225 million to settle lawsuits. So this is no longer a unique experience. It's becoming more and more commonplace. So why do we need risk-based testing? It's to avert these kinds of risks, or to minimize these kinds of risks, and therefore reduce costs, which helps us to improve performance, to reduce the cycle time. We get more value to our marketplace sooner rather than later. So what is this? What is it? What's risk-based testing? So let's start with some very fundamental approaches. Here you see a ship that's wrecked on a reef. Risk management is staying off the reef. So we want to be able to sail and get to our destination without a lot of excitement. So when we start to formalize that in terms of risk-based testing, the way we're thinking about this is integrating risk management with verification and validation. So when we start to integrate those two, we're getting a superior approach. And how do we do that? It's because first we're going to emphasize the identification of where our vulnerabilities are. And what are the consequences of those vulnerabilities if they were realized? So it's a future-looking perspective. And so that we are able to then verify and validate those things that are most important, the things that are most materially relevant and significant to our stakeholders. Those stakeholders could be internal because we want to turn a profit, we want to see net new revenue and that sort of thing. It can be external from our end users' perspective or for the people that are buying systems for our end users' experience. So the importance here is that we're beginning to formalize our approach through this integration, combining some of the best practices. By the way, risk management was studied along with the other knowledge areas that are found in the Project Management Institute's Project Management Body of Knowledge. And PMI charged Dr. Bill Ibbs with finding out which of these knowledge areas is most closely correlated with project success. In all the different knowledge areas, it turns out that risk management was most correlated with project success, and yet it was the least practiced in any shape or form with regard to project management, let alone integrating it into the way we go about product verification and validation. So it's a great opportunity for most organizations to improve their performance dramatically. So if we're asserting that what we need to do is integrate risk management with the testing process, here's just kind of a simplified, stylized view. In the red ellipse at the top, we're seeing that there are steps. There's a systematic approach to doing risk management, and it's integrated into the verification and validation process, primarily to inform what should we test, what should we test sooner, what can we test later, and as we'll see, what do we choose not to test at all? That may sound scary, but if we begin by accepting the assertion that it's in many cases not practicable to test everything, we need a systematic and credible way of deciding which things are the most powerful and give us the most return on investment to test. And those other things that have low multipliers are ones that we may indeed choose not to do at all. So here we're integrating this. We're going to take a closer look then at what it really means to do risk management informally and then more formally across kind of a continuum or formality in just a little bit. So before we do, let's just collect our thoughts as to why would we consider learning more about risk-based testing, perfecting our risk-based testing if you're already doing it, and increasing its defect detection efficiencies, for example. One is it helps us to really focus in on finding the most important defects. And generally that's going to be thought of in terms of the ones that are most costly if they leak through into production and into our end users' world, right? And be measured qualitatively or quantitatively. Some of the consequences might be if we let that defect go too far without detecting and correcting it. It's going to experience loss of market share. It may erode our brand. If we have to go fix the defect late in the cycle, we're going to have to divert resources from the next new big thing to fixing something that should have been out there working before. So it's a very costly endeavor. That's generally what we're meaning by important defects. And then as a result of that focus, we become more efficient as well as effective at what we do test. And we're going to talk a little bit about how to measure that improvement in effectiveness and efficiency. I'm going to give you an example before and after close to the end of our time today together. I don't know if you felt the pressure. Maybe you feel the pressure more at the end of a sprint or near the end of a project phase and so forth. But we're all under increasing pressure to deliver more value. Many of us have to deliver more value with less. We're living in what some call the Great Resignation, where I talk to folks and they're saying, not only do I have to do my own job, but I have to do the job of others because they're no longer here. A lot of pressure on us. So the idea here is helping us to make better decisions even as we're feeling that pressure and stress. and collecting the kind of information that helps to inform systematic, very basic process improvement. And we'll show you kind of a process improvement plan towards the end and what some of the results were of that from a case study. And very importantly is communicating with stakeholders. And what is it that they want to know about what's going on? Giving them a greater, more meaningful voice as really partners in the process of delivering greater value through building software and delivering it to the marketplace. So if we take a little bit closer look at communicating with stakeholders, let's examine. I wonder if you're a fan of checklists. I am. I'm an aviator. I learned a long time ago that checklists are helpful. Professional pilots, which I'm not, I'm an amateur pilot. Professional pilots are well educated, have college degrees, and yet they use checklists for everything. So if we think about what kind of risks concern decision makers and various kinds of stakeholders, internal as well as external, what do they want to know about risks? Here's a 7-point checklist for your consideration. And the first thing they want to know about risk is what can go wrong. Okay, what are today's risks? And some people will pridefully show, here's my risk register. It tends to be very static and represents a single point in time. And this first checklist item actually stretches beyond that and says, well, for any given of these risks, is it higher or lower than it was before? So there's this kind of trend analysis. So is it creeping up on us, or is it kind of fading into the distance? What's the story of the data that we have? And point 2 says, all right, now let's take a future-looking perspective. What's our forecast? Which of these risks is going to be getting higher or lower in the future? And perhaps it's because what we're doing about it. But for those risks that are emerging, the third point is, what are we doing to reduce the risk? And from a testing perspective, what we're talking about there is, what are we doing to identify risks? What are we doing to come up with tests in order to verify that a defect is present? How do we make the test more effective and efficient in finding those defects, particularly the ones that are important to key stakeholders, the most important risks to key stakeholders? And the fourth one is about accountability. Who owns it? Who's responsible for the risk aversion measures? Who do I talk to? Who's the go-to person to find out whether it's working out or not? And the fifth point here is, how will I know that our risk aversion measure is working? So if one of our risk aversion measures is we're going to verify the presence of a defect before it gets released, before it goes into production, what's the efficiency of the defect detection technique or strategy that we're using? In other words, how often are we finding a defect before it goes into production using this technique or that technique, using regression tests or an automated tests or whatever kinds of tests that you have in your portfolio of verification and validation kind of strategies. So you're going to want to know, how will I know it's working out, so that if it's not working out, it's either suboptimal or it's not working at all, I need to turn to plan B and plan C and plan D accordingly. How soon do we need to act? How soon do we need to begin testing and conclude testing in order to meet the timetable of release and production and field and commitments and service level agreements and all the rest of it? Because sometimes it's just too late for a risk aversion measure. It's just too late to begin testing now, because we can't conclude testing when the decision to release or not needs to be made. So this temporal aspect is also very important. People want to know about that. And then finally, when we identify a risk, and perhaps we've done some analysis to assess the magnitude of the risk, how soon is it coming? How costly is if we allow it to turn into a problem in the future? How do we go about testing, how do we go about communicating that, and with whom? How do we go about communicating with people internally, internal to our team, internal to our department, internal to our company, upstream to our suppliers, working in partnership, closely in partnership in a value stream with our supplier partners, and as well with customers. So best practice, you might be surprised if you're not involved with delivering services to Defense Department and, for example, the Pentagon in the United States. In fact, the Pentagon for quite a long time now, it's the law that if you're a subcontractor providing solutions, software solutions to the Pentagon, one has to demonstrate high levels of maturity of risk management and the ability to communicate bidirectionally when and where are we identifying risks and what are the consequences. So it's a very transparent approach that probably surprises many of us if we don't have clear visibility into how the U.S. government does business, at least in terms of defense systems. So I'm hopeful that as you consider this checklist of what people want to know about risks, just having a checklist like this doesn't in and of itself help you get good answers, but at least it helps you prepare how do I go about getting these kinds of answers, credible answers, useful answers that a lot of folks want to know. And when we get good and credible answers like this, what we find is double-digit improvements in performance of schedule and double-digit performance in cost performance. I'd be glad to, if you ever send me an email, we'll share that again at the end, my email, to give you data around that. So let's proceed and take a look at three things that help us as guiding principle. And one of our guiding principles is to actively attack risks. Because if we don't actively attack risks, they're likely going to eventually attack us. So here we're taking more of a proactive stance, and it starts with prioritization. What are the risks? Only the highest risk exposure is worthy of our further professional attention. And let's then test just those high risks earlier in the life cycle, because it's cheaper to find to test and find defects earlier. And often only the highest risk exposures are worthy of the most extensive testing, and our diminished extent of testing may be reserved for some of the lower risks, if any attention at all. So in the bottom left corner, we're going to be concentrating based on that prioritization that we communicate amongst the various parties that have stake in the outcomes of software development, is how are we going to go about allocating our test effort? What's our best talent that needs to be allocated to the most challenging risk testing and requires the most insights and experience, perhaps. Selecting wisely among a variety of test techniques, and we'll enumerate a few today. How do we go about intelligently retesting in a way that's suited for the kind of testing that's appropriate given the kinds of risks that we're dealing with right now and the kind of risks that we're trying to avoid realizing as problems in the future. So, and finally, in the lower right-hand side, is then having an informed approach to reporting test results, the status of how we're doing as we go along, day to day in our scrums, sprint to sprint, release to release, and in our journey in delivering solutions that are earning net new revenue at improved margins and so forth. So those are the three cornerstones of the guiding principle of actively attacking risks. And let's take an example here. Thanks for some of you that have joined us since we began. Welcome. And let's take a look at a situation where we have, let's say, half a dozen chunks of software stuff. I'm going to call them functions. I'm going to letter them. So we've got 6 chunks of software stuff, functions A through, G. Do we test all of these functions equally? Do we need to have 10 tests for function A, 10 tests for function B? Can anyone test any one of these functions? How do we go about allocating the resources for these functions? Well, the first question we're going to want to think about in its simplest form, and some of you may have a much more sophisticated understanding and current practice around risk management. We're going to get to that. We're going to build up to that as we go through our talk today. Let's take a kind of just a basic approach. They're not all necessarily equal because they may have differences in complexity. They may have differences among them in terms of the sheer number of inputs. Some of those drivers that challenges us to consider what's perhaps the infinite extent of the demand for testing. So the idea here is then to say, all right, for any one of these functions, for each of these functions, what's the likelihood that if we didn't test and find a defect, that once it leaked all the way into real world use, it would compromise the expected outcome by one or more of the stakeholders, either internally, externally, or both. Okay. So with that premise, we have a way of sorting our attention and beginning to think more deeply about how we're going to wisely allocate resources across the testing demands of these 6 functions. So if we look at slide on page 20, this is the least formal approach among the 5 that we're going to talk about. We're going to kind of march through a few more. Let's just start by, let's sort these 6 functions according to, by whatever means, our assessment of the relative likelihood of any one of these functions manifesting a shortfall of an expected valued outcome by a significant stakeholder, right? So you have to know who your stakeholders are. You have to know what their expectations are, how they value, both qualitative and qualitatively, the outcomes of any given functionality, and to what degree they have a sense of threshold for accepting or rejecting falling any degree short of what their expectation is. And so here you're saying we're dividing up the pie. So we have one pie of likelihood, and we find that the highest likelihood of falling short of stakeholder expectation is function E, and the lowest level of likelihood are functions G and F. So right away, we might have a clue here as to maybe we'll give more attention to the ones higher on the list as opposed to the ones lower on the list. Well, how do we come up with these likelihoods? There's a variety of sources, and there's more than what we have on the page here, but just a couple to consider is the users can say, you know, across the stuff that you build for me and I pay good money to buy from you, it more often fails in this area, function E and D. And they'll actually give you some sort of proportionality to their pain. That's one way. Another way is that we're actually capturing usage statistics. We know when there are failures and there are retries and so forth. So we're actually not so much taking qualitative data, net promoter score kind of data, but actual statistics that tell us they don't even use that functionality. And then we find out why is it? Because they don't feel it ever works sufficiently for them. So you might use some statistics, or maybe some of our marketing data tells us based on this persona or that persona of various stakeholders, based on customer demographics, that this is where there's is a perception of a higher failure rate. So given whichever source that we use, and that's kind of a whole nother matter beyond what we can accomplish in even a 90-minute session like we have today, let's take a look at what we might do with this. So if we take a look at slide number 21, we're adding an allocation of tests. So what we're saying, all right, so if there's a greater risk exposure in functions E, D, and maybe C, we're going to conceive of and hopefully have time to execute more tests for those. And we're going to give a little bit less attention to the development of tests for, let's say, functions B, A, G, and F. Okay? And so here there's just a very coarse breakdown of allocations to say, well, we're going to need to do, we'd like to be able to do 833 tests altogether for this set of functionality A through G. And we're going to test earlier, we're going to test more expensively functions E and D as an example. So this becomes part of our early planning. It becomes something that there's a useful conversation between project managers and test professionals. And then there's a deliberation of what's realistic for how much of this can we actually accomplish. Ideally, based on this outcome, we'd want to be able to run 833 tests. And how many of you are already thinking, yeah, but Scott, that never happens, or rarely happens. Maybe it happened once to me a long time ago, but not lately. So that's the real world, isn't it? And so if we think that, well, we only have time, we only have resources, we only have test beds, whatever it happens to be. Any of our constraints, it's going to be different for every organization. We only have resources for 556 tests. So that's my clever way of saying the first two rows, right? 441 plus 125. So then we say, all right, now we're thinking that we're probably not going to test functions B, A, G, F at all. And in fact, it looks like testing function C is also in jeopardy. So now what do we do? Do we actually plan to execute all 441 of the tests for function E and then beg, borrow, and steal rob Peter to pay Paul to say we won't do all 125 tests for function D because we'd like to do some testing for function C? Well, why might we consider that? Well, come on, the likelihood between 0.15 and 0.14, it's false precision, right? So maybe we want to actually, the smart thing to do might be to divide 125 remaining tests evenly between functions D and C, right? And now we're going to be talking about residual risk exposure, not only for functions B, A, G, and F, because we didn't test them at all, but between functions D and C, because we only had time to partially test across the two of them. So we're actively making decisions like this and helping to try to get some of this data to inform our decisions so that the outcomes aren't going to be perfect. What we find is that your outcomes are going to be dramatically improved. Again, generally seeing kind of double-digit schedule and cost performance improvement. Okay. So let's go on. And what we see here is that we just covered a relatively informal approach to risk-based testing. So in the leftmost column, it relies on a history from which we gather what the relative likelihood is, the experience of others. Maybe we have some checklists that we start to form that help us to prioritize. It's an approach that we consider on low-risk projects. It's something that we want to avoid, that modest level of informality, that low level of formality or rigor in a risk-based testing approach. We want to avoid that on safety critical or highly regulated projects. So if you're in the healthcare sector and medical devices and everything, that might be a starting point because it's maybe better than what's already happening. That's simply that early baby step to the elevator, baby step to the parking lot. That's kind of an allusion to Bill Murray's What About Bob movie. And there are a number, so that the idea here is that there are a number of approaches, generally increasing informality from left to right. The second column, ISO 9126, these are 25010, these are global standards. These are helpful because we can demonstrate that we're following industry recognized standards. It's more systematic than what maybe we just rolled our own or invented our own. There are very sophisticated approaches like the failure mode effect, usually more aerospace, high embedded technology kind of situations where the failure is very high cost. The risks are very high. We have to take a very conservative approach. Hazard analysis where there's physical safety involved. But we're going to take on the right-hand side fairly formal approach, and it's the ISO 16085 approach. And why? It's because, yes, indeed, it also follows an industry standard, one that was, by the way, shared with my longtime associate, Bob Charette. We applied this level of sophistication at Rockwell when I was at Rockwell International, particularly in what's now still an entity. It's no longer owned by Rockwell, but what's now Collins Aerospace. So we're going to take a deeper look at this. It's very helpful to consider that approach when we're on a mission critical or strategic project, and where we want to avoid it when it's just kind of an incidental, low risk, minor, small team, just a couple of us working on this sort of thing. Probably a little bit overkill for that sort of approach. So let's take a closer look at what that ISO 16085 approach might look like. So remember what we were talking earlier about, it's about asking those 7 questions and perhaps quite a few others. Well, how do I go about getting answers to those questions? Answers that are credible, answers that are useful, answers that people are going to find value in your helping them to get those answers. As a project manager, as a test professional, as a business analyst, a lot of different roles find that this approach is very helpful. So you see a diagrammatic representation, a very simple stylization of this process. You actually need to go to the IEEE and buy their, if you're interested in more details. I can't give you all of the details. It's fairly formidable. But it starts with something very important, and that's in the center of the bullseye. Objectives, assumptions, and constraints is that one really can't articulate a risk unless we have clarity about what is the business objective, that if something goes wrong, like an assumption is not true, or we have a constraint that we exceed, like it's got to be done by September 1st, but nobody on planet Earth in the last 50 years has ever done that much complex work by September 1st. So we're going to blow that schedule and probably the budget too. So how might an objective be placed at risk because we have false assumptions or self-imposed constraints that are not realistic, among a few? And we go about answering these questions, not only what the risks are and what's the likelihood, as we did in the informal, but what's the consequence? What's the magnitude of the consequence? What's the timing of the risk? Is it likely to happen to us earlier or later? Do we consider acceptable? What do we consider unacceptable? Do some of our stakeholders find this level of acceptance okay, and others find have a much higher bar, that they're very risk intolerant? So all those kinds of things help us to prioritize risks in a more refined and careful way, so that we're even better at considering and narrowing our focus at those and only those that are worthy of our professional attention and going forward. So that those are the only things in the final question that we consider an action to avert the risk, by coming up with a test, by coming up with a test plan, by improving our testing environment in order to test more rigorously and that sort of thing. There's an action that's going to be required to avert the risk, and usually that means a spend of time or money. Let's take another closer look at this. How do we go about prioritization? So two of those criteria that we covered in the checklist and in the last slide, excuse me, in the vertical is likelihood, and in the horizontal is consequence. So the consequence would be, if the risk, which is in the future, turns into a problem, how much pain would there be? What's the negative consequence? Okay, that's how we're looking at it in this situation. And so we have a simple, stylized, just for the purposes of discussion, quadrant approach that shows us that the higher the likelihood and the higher the consequence, the greater the consequence, in the upper right quadrant are the must-test items. And here what we're talking about is 5 different test techniques that we're applying for one area, one of the functions, for example, that warrant and in fact demand all 5 of those test techniques. We're not going to get into any detail about what those test techniques are. Many of you are probably pretty familiar with how to do those test techniques. But we're going to do 5 of those, okay? Now, if we take the opposite direction for low likelihood and low consequence, we may choose not to test at all. If we do choose to test, maybe we do some error guessing, which is very informal, not highly efficient, or we do some exploratory testing. We're going to just try to find out with some early testing how bad things are. Some of us call them smoke tests, or whatever. Will it fail as soon as you turn it on? That kind of thing. And then you have the kind of the gray areas in the upper left corner. Maybe we could test. We could do some boundary value analysis testing, or actually, I've got a typo here. The SEM should actually be. Let's see what I have here. Sorry about that. Ignore that one. I actually have a typo there. The idea is that we could test those, but we're going to emphasize and try to make sure we have sufficient allocation resources for the must-test items. Who knows how to do things? How many testers are sufficient for getting that done in the time frame involved, and so forth. So the upper left would be could tests, and the lower right, maybe less likelihood, but high consequence. Now we're going to do some kind of use case testing or some kind of real life testing. So the idea behind this is we have a prioritization technique that gives us focus on the critical few tests that we need to do. We start to have a basis for a conversation to help justify the resources and the time constraints and who needs to do what based on this sort of analysis. And if we take a look at slide number 26, what we see here is that based on risk exposure from above, very low, to farther down on the list, very high, we choose, based on risk exposure, an extent of testing. From no testing, that's a choice. And the most sophisticated organizations like Schlumberger, like AT&T, like Bell Northern Research, have demonstrated high degrees of performance, high degrees of net new revenue achievement, high degrees of profit margin, by making selected choices of not testing things because early indicators say you're not likely to find defects in that area. It's generally going to be defect-free. Whereas we have higher risk exposure in the cases as we go down this, that if you look at the comments, suggest a heuristic, if you will, of greater extent of testing, a greater number of tests that give us a rule of thumb to say, what are we going to do in this situation for this functionality based on risk exposure? So now we have a guide for a systematic treatment about what are we going to do this time for what we need to test today because of what we've done to assess risk exposure. And if you're wondering how we achieved in one word high risk exposure to low risk exposure, when I attempted to make the case in a couple of slides ago, and most of the people that have a project management professional certification know this well, is that risk exposure is defined as the product of likelihood and consequence. So here in a matrix or diagram table format, we say, well, how do you get a high risk, very high risk exposure? It's well where you have very high likelihood and where you have very high consequence. Well, how do you get a very low risk exposure? It's where you have a very low likelihood and a very low consequence. Just a kind of a simple, it's not the kind of thing an actuary would use, but something that's simple and actually quite practicable if you're thinking about doing something like this, especially for the first time. And a more sophisticated example is the one that we see here, where we have a weighted scoring approach. So here we have various risk drivers. And some of the risk drivers for likelihood are how often does the end user use this functionality. If they don't use it very frequently at all, it's going to be weighted less. If it's highly visible, it's going to stick out like a sore thumb if it fails. We're going to weight that more heavily. Similarly with consequence, we're looking at functionality, usability, maintainability. Some of you business analysts know those as the ILITs or the non-functional requirement categories. And so here we kind of multiply things out and come up with a figure of risk exposure in a calculated form. And people start to favor these because it makes it more easy to differentiate between high and low risk items. And here it's kind of suggestive that item A is going to warrant the most extensive risk, the verification and validation effort. Probably going to be testing those earlier because we're going to probably find defects earlier, and we want to leave some room for corrective action. In this example on slide number 29, we're becoming even more sophisticated. And what we're saying is there may be a multitude of likelihood drivers. We already suggested that in the last slide. And so here we're saying, well, likelihood of risk being, of a defect being present is going to increase with the size of the software, with the complexity of the software. If it's the first time we've done it, so it's new development. If we've reused it and reused it and reused it, and perhaps we're running the risk of reusing it on a mission that doesn't apply. The Ariane missile program in France reused and reused and reused software until on Ariane missile 5, they actually, 30 seconds after launch, they had to push the destruct button because they were reusing it glibly and didn't really do a proper risk analysis to make sure the software was fit for a brand new mission and for reuse. In this example, what we see here is, again, the likelihood and consequence in the those dimensions. And what we see is that tests 1, 2, and 6 and 4 are above what we call the risk referent and are unacceptable. In other words, it's only acceptable to do those tests. So those are done every single time. It's the basic threshold of quality before we release anything. And then if you look at the curve, and you notice here, it's not just the matrix or quadrants. We have a nonlinear curve here that represents people, different stakeholders, different perspectives, have different sense of risk thresholds and risk exposure. So what it says here is, but the CMO, the Chief Marketing Officer, isn't satisfied to release something unless we also test for 7, 9, and 8. That's her sweet spot. And the CFO says, well, it's not going out the door because the market, the shareholders are going to kill us if we don't ask. That's a figurative sense, by the way. Do tests 3 and 5 as well. So now we have different voices, different senses at going from upper right to lower left in terms of risk tolerance, and we have a growing sense of risk drivers for both likelihood and consequence. So let's take that sense of risk drivers and ask you to do a little bit of brainstorming, just a quick brainstorm session. So if you think about those kinds of drivers of risk, both likelihood and consequence, right now, what's top of mind? What have been some of the drivers of the likelihood of the presence of a defect so it warrants testing for the presence of a defect? Or where, if we don't find this defect, it's going to have a high consequence, and we don't want to live that, do we? So enter into the chat stream right now. What would be some drivers of quality risk? And Susan, if you could keep an eye on the chat stream or the Q&A stream, is just to share with us maybe a selected few of what participants are entering in the chat stream right now.
Sure. We have failure to back up if primary is offline. It seems to be the only comment so far.
Okay. You may want to think about that later. If you like a hard copy or of the deck, Susan, you can speak to how we go about doing that. I'd be glad to respond to emails to give people these checklists like we see here. There's a multitude of risk drivers, and we can use a checklist like this to say some of these might be relevant for my situation on slide number 31. And so the 8-step approach is we start by getting risk ideas like we were doing just now. We consult a checklist. We think about the things that we need to find. And we start to prioritize those in step 2 to which ones warrant more test activity than others. We keep in step 3 a track of which tests address which risks. And then we monitor our progress towards the execution of those tests to determine how, by the execution of the test and finding the presence or absence of defects, is helping us to determine are we reducing our exposure to risk, are we ready to release and deploy and go to market and so forth. So an example of monitoring the test progress would be that we have an enumeration of risk items like we've been doing in our webinar today, and we are ranking them from very high risk exposure to low. And we've identified a testing suite, tests 1 through 8. We see that some of the tests 1, 4, 5, and 6 are allocated to risk item 1. Some of those same tests are also allocated to risk item 2. And we also see that we have fewer tests allocated to some of the lower risk items. So that's not unlike what we were doing earlier about a proportional allocation of testing resources to the different risk items. And here we're talking about a real-time update. Some of the tests have executed and passed. Now, test passing doesn't necessarily guarantee the absence of a defect. One can only prove the presence of a defect. One cannot prove the absence of a defect. What we see here is looks like we've completed all the testing planned for risk item number 1. Test 4 failed for risk item number 2. The test 5 failed. We still haven't executed test 4 for risk item number 2. And we get an idea as we go along as to what our progress is. And so to finish our approach, we say, let's assess the coverage, not unlike what we just did, of how are we doing? How much of our risk exposure have we tested for? So that's step 5. To what extent do we need to retest? Where is that warranted? And where is it not warranted based on residual risk remaining? And let's not take this a little bit too seriously and go overboard. Let's go ahead and, based on our past experience and wisdom, test some things that are not necessarily risk-based to cover ourselves, because sometimes our risk analysis is a little bit off the mark, especially as we just begin doing risk assessments. And then finally, what we want to do from project to from sprint to sprint, from project to project, to build out based on our own history of risk taxonomies. There's a software risk taxonomy that's available from the Software Engineering Institute. You can Google and find things like that, associated with the Carnegie Mellon University. And so our final slide here is this. If you want to try something like this, you're going to find and enjoy improving your early defect detection percentage. And what does that mean? You're going to find more defects earlier than later, which means more defects found pre-production, fewer defects found in production. And one success story is represented here, where in the first 2 years, they weren't doing anything like what we discussed today. And then they rolled out a program where they trained people, they brought in experts to help lead risk analysis workshops. They began aligning their tests with the quality risks as assessed. They had coaches come in and help with the adoption or the organization change management, and as it was necessary to execute these practices. And then we go back and say, well, how did it work out? Well, if you look at this chart, it got better. It still wasn't perfect. But what we saw here in the years 3, 4, and 5, they were finding far more defects before going into production than they were before. And that resulted in improved perception in the marketplace as well, is that customers were experiencing improvements. That leads to things like improved net promoter score and better brand recognition and opportunities for growth of net new revenue and improved project margins. So we report out on, by doing the risk-based testing approach, we're improving in our performance. This is just an example of one improvement metric. So we explored risk-based testing. We talked about why it's needed. We defined it. We briefly went through 5 approaches, a little bit more detail in the informal risk approach, or the world standard risk management approach that's codified in IEEE ISO standard 16085. We took a look at thinking about drivers of risk, which begin helping us to think about what should we look for in our context in this situation. And we briefly walked through an 8-step approach that helps us systematically work on identifying a systematic decision support for in a smart way, allocating our finite project resources, and hopefully, as participants in the software development process and our customers as well, all the different stakeholders begin to enjoy a better quality of work life, professional work life.
Thank you, Scott, for presenting with us today.
Thank you, Susan, and thank you for everyone that attended.